So how blockchain works is that it's a peer-to-peer distributed software system out on the internet. And there are about 7,000 machines worldwide running the whole Bitcoin node. It's called the Bitcoin D node, the Bitcoin daemon. And you yourself are welcome to run this, to participate in hosting some of the peer-to-peer infrastructure for blockchain, for Bitcoin. And you would just go to github/Bitcoin and you can download the software to host a node and any of the software for how the whole system runs, and check it all out and create new proposals in improving the software and submit them back into the system. It's all an open peer-to-peer software kind of entity. And so these 7,000 nodes worldwide, you can check that out online, they're distributed globally. And the one issue is that to run the whole transaction ledger so far is already 100 gigabits. And so this is pretty substantial, and this starts to suggest the issue of scalability as a potential problem with blockchain. Now, what happens is there are different versions of our bridged software that carries just unspent transaction balances and active wallets and different kinds of streamlined versions of this whole 100 gigabit transaction ledger since the beginning of time. And so, for example, many phone-based applications will just carry a very simple ledger of exceptions or unspent balances to facilitate the speed of transactions. So this is very similar to when you go to buy gas and maybe you swipe your credit card at the gas station and they don't confirm your whole identity, but they mainly confirm that this zip code goes with this card and that the card is a valid card at the moment. So there's an abbreviated file of data related to fast transaction capabilities with credit cards and similarly with blockchain. Now, how the blockchain network works is that when all the transactions submitted, in the case of Bitcoin, every 10 minutes, those are collected into a block, and miners compete to be able to record that block. And I'll talk about that in just a moment. But how the experience to the user is that every 10 minutes, blocks are confirming. And so what that means is that one machine the winning machine from the mining effort will be able to confirm your transaction, shifting your ledger, your wallet balance to the other party's wallet, and that will be one confirm. So in 10 minutes, there will be one machine, the first and main machine, that confirms your transaction. Now, with every subsequent 10-minute interval, or after the initial confirm, then geometrically every other of those 7,000 machines running the full Bitcoin node will reconfirm and check that transaction. And so what that means is that the validity, the trustability of the computing system goes up geometrically over time as every other machine in the whole system confirms also that transaction. So what that means practically is if I'm just buying a cup of coffee with my Bitcoin, I don't really care. I'm assuming the transaction is going to confirm. I'm not worried about it. If I buy something a little bit more expensive, like a t-shirt, maybe I'd like to wait 10 minutes and make sure that the transformation confirms. If I buy something like a car, I probably want to wait an hour and make sure that numerous machines have confirmed that this transaction is valid and has gone through. And over time, it just expands geometrically the confirmation value of the transaction. Now, it's called a blockchain because, as I mentioned, every 10 minutes, all of the current transactions are collected into one block. And every subsequent block or batch of transactions, every last block calls the next block as the first element. So the block header of the next block will be the last part of the last block. And so that effectively chains together the ledger into blocks or batches of transactions. And then they're all out on the web in a sequential ledger, measured, time-stamped, and measurable over time. And next I will talk about mining.